Here's example 2 with using reference angles to evaluate trig functions. So when we did example 1, we talked about this and we sort of talked about it in depth and explained how to use this and things like that. So we're going to use this again for example 2 and the rest of the examples that we do like this. So anyway, what we want to do is first, if we use reference angles to evaluate trig functions, first we have to find the reference angle. Okay? And just like in example 1, we've actually already found the reference angle for this in a separate video. So we're just going to use that fact. We're not going to do it again. If you haven't seen that video, check the description for this video. There will be a link there to that other video where we get this reference angle. So anyway, we're just going to use the fact that the reference angle for this 3 pi over 4, the reference angle is pi over 4. So we're just going to accept that we already know that. But again, it's in a separate video. Check this description, the video description here, if you want to see that video. So anyway, now what we have to do, we're going to use this fact here. Okay? Cosine of theta equals plus or minus cosine of our reference angle. Where this sine, SIGN sine, depends on which quadrant theta is in. Okay, so our theta is 3 pi over 4. So, and remember, this is also true for all 6 trig functions, not just cosine. Okay, so anyway, so let's go ahead and draw 3 pi over 4 so we can find out what quadrant it's in. Well, notice that's a special angle on the unit circle, right? So let's go ahead and draw that. So we know that's in quadrant 2. Okay. Okay, so 3 pi over 4 is over here. Okay. And again, just like in example 1, you might say, oh, well, since it's on the unit circle, can't we just say cosine is the x-coordinate, sine is the y-coordinate? Yeah, we can absolutely say that. But we want to see a different way of evaluating this sort of thing here. Okay, we want to do this a different way. Because for a lot of times for evaluating trig expressions, there's many ways to approach different techniques to try, things like that. So this is just one more of many different ways. So we're going to go ahead and continue with using reference angles here. Okay, so 3 pi over 4, what do we see here? 3 pi over 4 is in quadrant 2. So 3 pi over 4 is in quadrant 2. Okay. So what can we say about the SIGN sine of the cosine and sine functions? So since 3 pi over 4 is in quadrant 2, then, so 3 pi over 4 is in quadrant 2, so cosine of 3 pi over 4 is negative, right? Remember, if you're in quadrant 2, the cosine is negative because cosine is the x-coordinate, you're to the left of the y-axis. Okay, cosine is the x-coordinate on the unit circle. And the sine, what about the sine, the trig function sine? Well, if you're in quadrant 2, you're above the x-axis. The sine corresponds to the y-coordinate on the unit circle, so above the x-axis, y-coordinates are positive. So the sine of 3 pi over 4 is positive, okay? Okay, so now that we've established that, we know how to apply this exactly now. So what we know is that cosine of 3 pi over 4 equals, we'll just use blue again, cosine of 3 pi over 4 equals cosine of pi over 4, okay, because remember pi over 4 is the reference angle for 3 pi over 4, and we established that in an earlier video, so we're not going to redo that. But it's not exactly cosine of pi over 4, right, because remember we have to consider the sine, SIGN sine, and we just found out that since 3 pi over 4 is in quadrant 2, the cosine of 3 pi over 4 is negative. Okay, since the cosine of 3 pi over 4 is negative, we got to slap on a minus sign over here. Okay, so that's how that works with reference angles there. And cosine of pi over 4 is root 2 over 2, or you could say 1 over root 2 if you were one of my students, that's fine. But this will just say negative root 2 over 2 in case you have to rationalize the denominator. Okay, so that's our answer for that one. Now what about the sine? Okay, well sine of 3 pi over 4 equals the sine of pi over 4 up to a possible minus sign out here. But remember, sine of 3 pi over 4 is actually positive. Okay, so since sine of 3 pi over 4 is positive, we don't put a minus sign here. Okay, so it's actually the same. Okay. Root 2 over 2. Okay, and why are we saying this? Like, where do these equalities over here come from? They come from this fact over here. So remember, if you want to evaluate a trig function at an angle, evaluate it at its reference angle, okay, which is usually going to be simpler or easier. And then you might have to worry about a minus sign out in front, and that minus sign depends on which quadrant theta your original angle is in. So that's just what we did here. Since our original angle 3 pi over 4 is in quadrant 2, then the cosine is negative, the sine is positive. So that's why this has a minus sign in front of it. Okay, so this minus sign right here. Okay, and that's why this has no minus sign, because the sine, SIN sine is positive, okay, in quadrant 2. Okay, so that's example 2 with using reference angles. More examples coming up later.